Well, so by way of introduction, this is the webinar from Centauro for your Drupal Commerce website doesn't have to be slow. And of course, we picked this subject because many projects that we come into, whether they were developed by other agencies, by individual developers, by in-house teams, or just kind of grew organically over time, they actually are slow. And so we're here to share our knowledge as the maintainers of the Drupal Commerce modules. And I'll let Tom introduce himself. I'm fairly well known at this point as the kind of progenitor of Drupal Commerce, starting back in 2010, and UberCart before that. But in my day job today, I'm primarily in a sales and marketing role at Centauro, while also serving functionally as more of a product owner at this point of the platform, not the primary developer for some time now. Tom?
Sure. Yeah, my background originally started at Apple and have worked on many large sites there, going back quite a few years. And over the years, eventually got onto Drupal and have built some of the larger Drupal sites that we have, including a government website collecting tax and payments, doing about $500 million in transactions per year. And yeah, recently, another retail site that we had also doing about $250 million in transactions a year. So I'm used to working on large scale sites. So I mean, finding things that are slow and making them not slow is kind of right up my alley.
And a lot of fun.
Yeah.
Especially when the builds don't take 20 minutes.
Absolutely.
Well, so that kind of gives a little bit of our background. Obviously, we are, our ideally credibility on this subject just comes from our history of the project and our track record. But the other thing that we just wanted to reiterate is that across all of our projects, the problems are consistent. Rarely do we find new problems. Although we didn't discuss this before the call, Tom, but I did have one project that we came into that was pre-rendering the checkout review page on the initial checkout step, I guess to save time later, and then stuffing it into Drupal's variables table and then never evacuating it. So every page request had thousands of these pre-rendered HTML blobs being unserialized in memory, which of course killed MySQL's memcache and various other things. So sometimes you do still find new stuff, but generally speaking, these problems are consistent. And obviously, we want to help solve those problems. If you are managing your own Drupal Commerce site, if you're responsible for a Drupal Commerce site or sites as a third-party or external developer or agency, we want you to know that it's probably not the platform, right? There are probably things that you can do to make sure that when that next sale day rolls around, it's not going to crap all over itself. There's probably things, in the build itself, both the configuration, but also often like the hosting infrastructure that you can toggle or tweak to make the site faster without a rebuild. And that's really, one of our primary messages, because oftentimes when people do come to us, they have a long history on Drupal Commerce, and we're kind of their Hail Mary. And I've literally heard, within the last several months, CEOs tell me, I guess if you guys can't help us, then Drupal Commerce just isn't for us. And their alternative is literally to rebuild on a new platform with unknown problems and hope that it goes better the next time. And I know that's it's not never the solution, but it's not always, and maybe not even often the solution. Tom, would you like to kind of delineate for us the difference between performance and scalability? Because I guess I understood this before I saw this particular slide from you, but I hadn't put it quite so clearly.
Sure. Yeah. Performance. We all want performance. We want everything to be fast. one thing that can be misleading is you might have a developer demo something, a feature or whatever, and it's fast. It's fast on their local. It's fast when there's one user on the site. Everything's fast then. There's only 10 rows in the user table. There's only like 5 products that have currently set up. Everything's fast when there's no data. It's different though when you start having systems where you've got hundreds of thousands of products, when you have millions of orders, millions of customers in your system. That's a completely different level. And obviously, people are in places all in between. You might have a smaller customer base, a smaller product catalog, maybe not hundreds of thousands or millions. But if you plan for the hundreds or thousands or millions, if you architect that way, then during that entire process, you can just focus on working on features and not worrying about scalability all the time. So if you build and architect along the way, you don't even really have to worry about these. But you do have to do these up front so that you're not constantly fighting a battle along the way. And yeah, what we want to see is scalability. For me, when I think of scalability, I'm thinking of like a Ticketmaster, Taylor Swift ticket drop, on a Saturday morning at 10 a.m. And you have all of these people hitting the, I want to buy a ticket button at the same exact time. I always think of that in mind when I'm architecting anything, because if I solve that, then everything else should pretty much just work. So starting from that problem rather than just the, hey, I can add something to my cart and check out and it works. Anybody can do that. But we want to make sure that you build out to a scalable platform, because we know all of us want to grow, and we expect that you're going to have more customers and more products and more sales next year and years beyond, and we want you to be able to scale out.
Actually, just to blow my mind, in the shower this morning, I was talking to Siri and I said, Siri, I hope my phone doesn't activate right now. How many orders a day does Amazon process? Tom, do you want to take a stab? How many orders a day do you think Amazon processes?
Gosh, I'm not even going to guess.
Okay, 26 million. They take in 700,000 orders an hour. It's unbelievable. I assume that's not international. That could just be US. I would assume it's international, but the scale is just like mind-boggling. Oh man. Well, so the numbers that we're talking about, that Tom's shared, that we have in these slides as well, are from real projects that we've been a part of. So we just want people to know. I have a little poll running for people to kind of weigh in, like what is the general scale we're talking about here. We've had customers who are national conglomerates, incapable of taking in even tens of orders per day. The classic example is that one that I said, was really violating their database and their variables table with some very poor architecture decisions. So in other words, the problems that we're solving, they're for orders that are of any size, or sites of any size, really. And some of them actually more dramatically impact smaller sites, because a smaller site means oftentimes smaller budget, smaller infrastructure spend. You actually need to get more out of less, and you can't have your site being hosed by bots, training LLMs all over the world on your data set. So scale doesn't necessarily determine the pertinence of the information here, but we do want to be clear. Like, we've had sites that were processing massive amounts of data. This is the classic example that Tom shared, where essentially a site during the pandemic, during COVID-19, needed to stay online to deliver critical, essentially pandemic infrastructure to the United States, and it was able to serve millions of requests, host thousands of concurrent users. Stand up. Tom, I can't recall off the top of my head. I'm sure that we had glitches, but I don't remember any significant downtimes on that project.
We actually really didn't, and that was one of the things that the CEO from that company, had shared with some other team members, is that he'd been on like 50 kind of similar, like large scale kind of launches, and this is like the first one out of those 50 that went smoothly.
That's great. Yeah, and a huge thanks too. It bears mentioning that we had a great partnership with Acquia on this particular project. where they really customized the infrastructure to make sure that this customer could stay live. I think that was a big part of it. But obviously, the lion's share of the optimization happens first in the software layer of the application itself, but then also the software around the software, which did include Aqua infrastructure, but other things as well. So, for example, and I'll toot Tom's horn, since I'm sure Tom's not going to want to toot his own horn, but Tom was the master architect, and the first thing you have to do is just don't make decisions that you're going to have to contend with later. Don't paint yourself into a corner. He also highly optimized Cloudflare, and we've now reproduced Tom's unique knowledge here across multiple projects, basically any project that we're taking live or inheriting and improving, so that the lion's share, the vast supermajority of requests are being served from the edge, meaning on somebody else's machine, not your application server. That way, nothing really has to come to the server until a user is actually authenticating or building a cart. And even once they have a cart, insofar as you're able to, you're serving cached content and lazy loading dynamic page elements. And finally, load testing well ahead of time. And Tom, I mean, these numbers just speak for themselves. I mean,
yeah, they and you mentioned Aqua. Their team actually did some of the load testing, and yeah, they were running tools, and they said they noticed got to 1,000, 5,000 orders an hour, everything was fine. Little drop in performance, minor, a few percentage points drop in performance when we got to 10,000. They said, but it stayed consistent all the way to 30,000, and they had to stop testing at 30,000, not because of the site, but because their load testing tools ran out of load testing workers. So we expect that it probably would have scaled even bigger than that, but I didn't have the chance for them to basically onboard more workers into their tool set. The other thing that we ran into is that the site held up, but we actually had a physical limitation. Now, the lab actually has more capacity than this, but they have lots of other tests that they need to run. They can't just, put all the capacity towards one test. And basically, the physical lab had allocation for about 30,000 a day. So even though we could take in 30,000 plus an hour, we actually had to cap at 30,000 a day just because of the physical lab capacity.
always nice when you're able to handle literally, what is that, 24x the throughput. There's quite some cushion there. Another one, and this one was one that I worked on directly myself some years ago. It was one of the big major, music labels in the United States. I essentially had a throughput issue, and really, it's not exactly the Taylor Swift scale problem that Tom mentioned earlier, but they did have major recording artists that every time they attempted essentially an advertisement, it would bring the site down. And of course, this was disappointing to them. And unfortunately, they thought their only option was to leave Drupal. And then only after they decided to leave Drupal did they come to us and say, hey, we're in the middle of this migration process. Is there anything you can do to help us out? And I said, yeah, let's change the transaction isolation level on your database so that you actually aren't locking your entire orders table every time you load a cart. Boom. It literally 10x their throughput from that one change. And so we're you have to look for bottlenecks as much as you also have to look for that sort of mega scaling. Sometimes there are just bottlenecks, and we reproduced that one. This was during the Drupal 7 era. Drupal 8 and beyond is much better about this out of the box. Although updated databases and copy tables, you still need to double check this, but or hard-coded configurations and settings that PHP files we've seen where the transaction isolation level was not what it ought to be. In any case, we've seen the same change again. We had an online retailer. I've talked about MathSmart before at Drupal Cons. That's a client we can name, doing thousands of orders per hour. And basically this was part of what got them to scale up to just thousands of concurrent shoppers. That one on Upsun, or the artist formerly known as platform.sh. We'll cover exactly the problems here, but the issue is that replatforming is not necessarily the solution. many of the problems that you're going to face are portable. They'll follow you to the new platform. Just simply put, and on other platforms, you may not have the ability to even inspect the database, for example, to understand why it's slowing down. Or it may have a platform architecture that actually requires you to incorporate third-party data sets, which adds an API request and latency to every page request that you can't get around because you don't own the data model in your Drupal database. You're also paying twice basically for the performance scalability. You're going to have to first replatform and then still solve the same problems. And all of the great reasons that brought you to Drupal in the first place are likely not as portable as the problems. And so you're going to leave behind your open source community. You're going to leave behind the flexibility at the data architecture layer, the data ownership, the customer relationship ownership, all the things that make Drupal Commerce compelling. Unless you're literally going to another open source platform of equal capabilities, of which I don't believe there are any, although some are good enough, you're losing something, but not necessarily solving your problem. And last but not least, because this one comes up quite a bit, is that a lot of people think, okay, well, if I've reached the extent of what I can do with full stack Drupal, maybe I don't need to go to BigCommerce or Shopify or Magento. Maybe I need to decouple and use Next.js with Next Shop, or go to Vue with Vue Storefront, or whatever the different options are out there today. And we are not against decoupling, qua decoupling. We actually have a major decoupled side. That's the Matt Smart case study, fully decoupled, great. But it is not the silver bullet for performance issues that some people think that it is. We have had fully decoupled clients do just fine. We've had others that it actually was a regression in both performance and stability of the platform.
Security as well.
Yeah.
You've got two more, an additional layer there. You know, you've introduced, you're now not just coding that middleware that Drupal now becomes, but now you've got that front end, and so now you've got a much larger code surface, and so and then there's security implications when you start talking those multiple layers there.
Right. Yeah, we've seen, for example, in recent migrations, clients that went from being full stack to being headless, having API endpoints serving up content that should only be visible to authenticated users. But the endpoint wasn't constructed in the same way that the full stack side had been. And so they were disclosing data they didn't intend to disclose. And at the very least, decoupling requires you to develop every feature twice. And so if you do want to optimize the way something works, I mean, it's different concerns. And the issues are still the same. You're not maybe caching a fully rendered page, but you are having to sort out caching for API responses. You're not having, there's just, I don't know. It's not a silver bullet. We're not against it. Happy to talk about decoupling in a separate presentation. And then last but not least, obviously there are people for whom migrating is a fine solution. So lest we say, yeah, you should always stay on Drupal Commerce, and if all you want is a $10 a month, or $20 a month e-commerce website, here's how to make it happen. But actually, you could get that using Commerce Kickstarter on a shared VPS. Maybe not the best approach, but in any case, for people that need it, by all means, the SaaS platforms can be good enough. But we know you're here to get to the meat, so let's get to the meat. The very first thing that we'll get to is caching, because I'm not going to say that caching is always the issue, but caching is often at least part of the issue that's slowing a site down. And just a real quick word, I do see your question, Rick. We'll get to that in the database section now of the meat of the presentation here. Tom, like walk us through your thought process here when you're coming into a new site and all we know is it's slow, make it work.
So the first thing we want to think about is that the application server layer is the most expensive one, but it handles the most important one, which is that's where your business logic lies, and that's where we want that computational power to be. But we don't want that application layer to be dealing with, serving up script files and images and all those kinds of things. The image for me or you or anybody else, is generally going to be the same. There's probably some weird, rare edge cases, but generally we're going to see the same pages on the homepage. So what we want to see is we want to put an edge in front. So, whether it's a Cloudflare or Fastly or other, similar products, we want the edge up front, and we want that to take 90 to 99% of the workload, because it's just going to return it faster. They have distributed servers all over the world. So, somebody who's in LA is going to get, a West Coast server giving them that file very fast. Somebody on the East Coast is going to get New York. Somebody in Europe is going to get a European server. They're going to get all of these static files very quickly. And when we can take that 90 to 99% of the load and handle it there, that means we're, 10, and hopefully down to 1% is actually going back to the application server. That's also important from a cost perspective, because that's typically our most expensive part of the layer. So, we want to make sure that those hosting costs come down. But by reducing that allows us to then concentrate on the performance of that application layer. So that's really what we want to do is cache up front anything that's static that can happen there, and then reserve all of the application server for the critical and important business logic. One thing that we run into here is people will have issues where it's not caching enough, then they over cache. And then we have the opposite problem where, like, this one thing is being cached and it shouldn't, and they're not sure how to fix it. And so what they end up doing is they just basically purge all of the cache. And now you're in this problem where it's even worse than not caching in the first place. They're caching and then they're removing everything, and they're caching and they're removing everything. And you end up in an even worse issue, because now you're just hammering your application server and your edge server with all of these requests to cache and then purge.
Yeah. So, I mean, like, sometimes, like, the very first thing we do coming into a new project, just kind of like, just look. I will routinely even just go to our client sites and just inspect. Am I being served anything from the cache? Okay, why not? Let's go take a look. And if you're not familiar, I mean, that there are. Oh shoot! I guess we need to make a tutorial, Tom. There are tutorials out there, I'm sure. But basically, you're opening up developer tools, watching the network traffic, seeing for the actual HTTP request. Are you getting any cache hits? If so, where are they coming from? There might be multiple layers of caching there. It will tell you, who is serving up this response. And if the answer is always miss, it's being served by origin. Okay, you need to figure out what's going on there. And I will say too, even origin requests could still be getting some forms of caching. And let's get into those different levels of caching. It may not be coming from the edge, but maybe there's some caching at the database level or elsewhere that's helping to construct that page. But not to belabor this point, but Tom, mentioned it, is that just because caching is enabled doesn't mean that it's working. And that's why you have to, even if it's enabled, you still need to go and actually look at the front end and make sure that it's being, that content is being served from the cache. We had this, this large retailer that we recently helped overcome some performance issues, and it turns out that they had, a large allocation of resource to Varnish, and had legacy Redis configurations as well that were no longer enabled. And so basically neither one of them, the Redis, by virtue of being disabled, wasn't being used, obviously, but Varnish also was never being hit. And so every request was being served from the origin. And what's frustrating in that scenario to the merchant and to the developers, and again, like, we miss this too. Like, we're not perfect, but it's when you put all the work in to do what you think will increase the performance, it's frustrating to see no improvement. And same for Cloudflare. That merchant, but other merchants as well, even in recent launches, had Cloudflare, proxying requests to their web application with no rules properly configured to actually serve anything. We had a Next.js front end that was never being served from the edge. It was always being served from the application server. Not a huge deal. It's mostly static files being served from a web server, but those are still, HTTP processes from a limited pool that have to be opened in order to serve that content to users. So, the important thing is just say, okay, even if it's enabled, it may not be working. Why is it not working? Perhaps something is quietly breaking the cache. And a biggie here, so Tom actually, this was Tom's slide. Tom points out that, like, personalized cart blocks and headers that are showing the number of products in a cart, etc. Like those, of course, have to be, those numbers have to be generated dynamically, but that doesn't mean the entire page has to be generated dynamically. The dynamic portions could be lazy loaded. Tom, is that actually is that where the lazy builders come into play? Drupal will use BigPipe to push out the lazy rendered personalized portions after the rest of the HTML has been delivered. Is that the idea?
That's correct. And so that's what we do on product display pages. That's what we do on the cart page, or the cart block, so that no matter what page you're on, you might see a little cart block up top that says you have 3 items in the cart. That's lazy loaded, so that the 99% of the page that is static, or essentially, close to static, updated maybe every few weeks or months, that's always cached and loaded quickly. And then it's only that little cart block that's actually dynamically loaded. Now, Drupal Commerce, we do that out of the box for add to cart. We do that for the cart block. But if somebody might create a view and then might put that view in a block, and then might put that block on their page. Maybe it's a sidebar of items that you might be interested in, or things that are on sale today. And that's awesome from a marketing perspective. You want to push out that content. But if you're not building it correctly, suddenly all of your pages are now not cacheable, because that view is set up to have a 5-minute cache or a 1-minute cache, because you want to see the most recent products. So that's where that becomes important, is we want all the static things that are on a page, the things that don't change very often, to be cached and performant in that sense. And then the things that are dynamic, we're just dynamically loading and lazy loading just those little bits and pieces. So it's a balance.
Mm-hmm. Yeah, a great example recently, we helped this international laboratory and pharmaceutical supply company upgrade their site from Drupal 7 to 11. And one of the things that blew my mind was that their product catalog is vast. We're talking just over 1 million SKUs. It's pretty significant. And they ended up basically serving all of the availability and pricing information from a Solar index that they custom populated and then lazy loaded into the PDP. I thought it was ingenious. And so just they're saying, hey, like this availability figures per person or per market pricing, like this is all dynamic. We need the PDP to load. And then if it takes another second or two for the separate request to generate this sort of complex add to cart form in browser client side, so be it. So great stuff. Another thing that quietly breaks cache is the private temp store. So just to call that out, if you have if you're using a module that is caching it, like stashing, we'll say stashing something in a visitor's private temp store, that initiates a session. So that turns an anonymous visitor not to an authenticated, but at least to a sessioned user, breaking cache. And one of the most notorious examples from recent memory was the Google Tag Manager module, using the private temp store to stash events and push those out to Google Analytics. It was breaking cache on these GET requests. Like, hey, you're just viewing a page. So yeah, you have to look for things like that. Again, we're not perfect. Our first pass at a year model make selector for an automotive parts website was using the private temp store to store that selection when local storage client side could have done the job. So that's one of the things just to bear in mind is, like, if I can use local storage, if I can store the data or the configuration that a customer's making client side and then react with that asynchronously, great. Another good example of that is this conglomerate we worked with years ago had a comparison cart, and they just used the commerce product comparison module that was up on Drupal.org, and it basically created a comparison cart of product data that would break cache. So you build up a comparison cart. You're not actually yet at the point of making a purchasing, of buying. You're still trying to evaluate things. And I said, hey, like, this doesn't have to happen server side. I don't care to retain server side what products people are trying to compare in my website. It's good enough for that to be tracked client side, and then to have a comparison page that is just making an API request to fetch the relevant product details across these comparison products and render that chart client side. That was, an obvious win, to then continue to serve all the rest of the pages that somebody would view when they're, navigating their way through a large product catalog from cache. Anywho, I think we belabored that point enough. You got to watch out for the silent cache killers, and these are some of the fundamentals. Tom, again, I know that this is kind of near and dear to your heart. What was the? We had an example recently, right? That automotive company. I mean, they were just getting anonymous head requests, right? Just DDoSing the site for no good reason.
They were getting somebody wrote a script somewhere in the Midwest and was just firing away at their server and just sending essentially
like a rogue uptime monitor.
Yeah, it could be something that they were that somebody put in place to just to check if the site is up, but it was sending thousands of requests per minute, and of course that was going to the edge layer at Cloudflare, but then it was hitting the back end on the application layer and making the full round trip. And so both the edge layer was getting hammered and the back end was getting hammered. In this particular case, we knew this was a rogue thing, so we basically blocked it. But again, this is where, if the edge could have handled it, it would have saved a lot of stress on the app server up front. So once the caching rules went in for that, then that saved them there. But yeah, some of the other things we talk about here is like the cache hygiene. One thing that can kill your site is marketing parameters come in. So the UTM underscore parameters, FB, CLID, the Google, click parameters. Yeah, all of these parameters come in, and to a normal application server, these just look like different query parameters. They don't know the difference between those or search parameters. If you were on a search page and you were filtering by a make or a model or a year, if it was a car site, for example. So what we do here as well is, Cloudflare, we're able to strip out these keys because these really only matter on the front end. The JavaScript's using it on the front end. It generally doesn't matter that it needs to get to the application layer. So we actually have Cloudflare strip all of these out so that the request is just the actual, say, homepage or the specific landing page that's being marketed on Facebook or Instagram or wherever it is. And that page is the same for all anonymous users. But the application server and the cache layer initially thinks of them as different requests just because there's like 1-digit difference in one of those parameters. So by basically cleaning those out before the request even is considered for caching and is sent to the application server, that makes a world of difference as well on the performance there.
Yeah, I was thinking about the cache key issue. I mean, I think in particular, gosh, maybe you remember the site, Tom, but basically, if your cache can only store so many objects, and people are just bot crawling your your faceted product catalog, and these pages are getting cached. I mean, at the end of the day, you're going to end up with a very full cache and very low requests actually being served from cache. That's kind of the tell, I guess, is to look for. Wow, my cache is full. I'm redlining my memory, or I'm running out of disk space, or whatever. And yet, observably, very few requests are being served from cache. I mean, that's a tell. Maybe you're caching the wrong things, caching too much of the wrong thing, or not evacuating the cache, not expiring, objects fast enough. Things, common tells to look for. And just like you have to clean up your cache, you also need to manage the technical debt in the code base itself. And this is one that's I've seen multiple times. I mean, for the last 15 years, Drupal projects have a long life because people do adopt the platform because they want to be able to continue building on one application for years. And really, the longer you remain on the same site, it's almost like the more benefit you derive from the platform. You're building out systems, and you're building out components, and you're building out essentially all these atomic units of functionality that over time you're weaving together in ways that make for very powerful, robust e-commerce applications. But one of the drawbacks of that is if you don't go back and clean up the approaches you're leaving behind, And we see this most often when it's just one person in charge of the site, and they're typically overworked and really subject to the whims of the demands of the business on a daily basis. You might end up leaving stuff around. And I use one example here on the left-hand side. I mean, this is a major international, I don't know, Fortune 50 company where essentially, just multiple teams over multiple years, introduced into this project literally every single layout building and page building tool available to Drupal. And that adds overhead. I mean, the Drupal's evaluating things regardless, and it's rendering each of these things in different ways, and it's caching the different outputs of these different things in different ways. It's just really hard to manage that. We actually saw one customer that was rendering very expensive things. Essentially, I think it was forms built using Vue's forms. All right, so the most expensive way you can build a form and drop it onto a site, and then putting it into the product catalog grid, and then hiding it all via CSS. So, oh, that's not performant. Remove those forms from the catalog pages. And so they removed them with display none. So of course, as we all know, incurring the full performance cost and not actually solving the problem at all. And so, you have to mind your technical debt. You also have to mind the elements that have been clicked together in the user interface, because Drupal's great at giving people a GUI, a graphical user interface for doing pretty complex things like construct arcane database queries that reach across 6 different entity tables and render outputs to an end user. But that also has the drawback of creating non-performant queries, non-performant pages, non-cacheable pages or interfaces that actually just don't work. If you've ever tried to randomize a product catalog or search result, for example, with an embedded add to cart form, you know that once that page is submitted, if it's randomized, well, that add to cart form is going to fail. Bear these things in mind, especially if you're the sole developer on a project. Advocating for garbage collection, if you will, at the configuration layer, and audits at the configuration layer is important. And I think we have multiple enterprise accounts, folks that would be in the hundreds to thousands of orders a day tier from my poll, where they have these in-depth product catalogs, incurring the full cost of querying these depths of category levels, even where there's no data whatsoever, or where it's just irrelevant to the query. Also, we don't even have this in this deck. If you have taxonomy vocabularies that stretch into the tens or hundreds of thousands of terms, that's its whole own performance optimization that you're going to have to look out for, particularly with respect to the tree, where Drupal wants to load the full tree. There are other concerns there around optimizing for taxonomy trees that we don't even mention in here, but that's a good one to look out for. And ultimately, just knowing the shape of your database and being able to do actual database slow query inspection and performance optimization is key. Tom, I think you're particularly good at this, so I'll let you handle this slide.
Okay. Yeah, definitely on your database. Indexes are your friend. They can also be your enemy. So something to think about. Indexes help you be faster searching for things. So you definitely want to index things that you're going to search on. Obviously, first name, last name on a user, an email address, things of that nature. But you want to be careful that you don't index too much, because index do present a cost every time a record is inserted or updated. It's now updating multiple indexes. So if you have 5 or 10 indexes on a table, every time you do an update, you're not just updating that one table, you're updating those 5, 6, 7, 8, 9, 10 indexes. So again, it's a balance. You want to add indexes so they help you on the select side, but you don't want to add too many that it's hurting your insert or update performance. So there's always a balance that we want to look for. One thing we don't want to do is we want to avoid contained searches. Sometimes these seem kind of cool, but if you do a contained search, it's essentially, and I don't know how many people still remember using phone books, But this is kind of like handing somebody a phone book and then saying, find every person in there who has the letter A in their name. Now it's easy to find people whose last name starts with A, but not every single record, every single phone number, listing in the book that contains the letter A. And that's essentially what we're doing when we do a contain search. So we typically want to have searches that are going to be a starts with, because that's going to use an index. If you're doing a contains, you're not using an index. It's actually doing a full table scan. It might use an index, but it's going to do a full index scan. So it's going to look at every single record and not just kind of zoom in and get to the page quickly.
And kind of a subset of that is that if you're doing a contains query, because you just have a blob of data in a text column, and you're just trying to search within that blob to generate a query, which we've seen many times. Really the fix is to denormalize your data set, or rather to normalize it, sorry. You have one denormalized blob. Normalize the parts that you actually need to query on, the actual elements that you need to sort, filter, or otherwise query on. And the classic example of that is we don't just store address data in a text blob. We found a standard, the XNAL standard, and we have each of the different components of an address all over the world in its own field in the database. And that just lets you optimize better.
And that actually works well with the slide you just left. But if we go back there, this is one thing that we run into. We'll get onto a client site and we'll find that they have hundreds of fields on their different entities, on a product, on a user, and so forth. And address is a great example of a way to basically put things together, because we're not creating a field address line 1 and a field address line 2 and a field city and a field state, field zip. There's a field address, and it knows of all of those. I think there's about 10 or 12 fields on there. I can't remember the exact count, but with address line 1, 2, 3, you can have company name, first name, last name, and so forth. There's about a dozen fields on there. That's all stored in one table, and they're all built together. So if you have, say, an integration with a remote system, and there might be 3 or 5 or 10 fields that you need to, keep in sync with that system, don't create 10 individual fields through the UX. Create a custom field. And when you define that custom field, define all 10 together. That way they're all loaded and unloaded and updated together. And that makes it much more performant. In Drupal, you don't want to have hundreds of fields defined separately. So when you can do things and consolidate it, and to me, address is probably one of the best examples of that.
Mm-hmm. And as a quick time check, I know we're nearing the end of our scheduled time. We're going to run through these slides. If you need to drop, obviously we'll send the recording out. I guess we just bit off a little more than we could chew in the time we had time. But speaking of integrations, we can speed up a little bit here. To the extent that you are integrating third parties, I mean, there are relatively few things throughout the customer journey that must be synchronous. Payment, of course, is the classic one. Some sites, there may also be third-party pricing engines that come into play, or third-party tax calculation engines. But when it comes to knowing how much somebody's paying and collecting that money from them, typically synchronous, but asynchronous things should be moved to queues and processed from, queues. We typically use advanced queue and just let that run from a worker, from a server daemon or whatever. Obviously, anything that has to be synchronous still should be. But if you're just sending an email, that doesn't need to be sent either by the page request before content is served, or even as part of a destruct process after the request is served to the content. Because even if you're doing stuff on destruct, that PHP worker is still active and blocked and not available for somebody else to then make a page request. So move those things to an asynchronous queue. And by extension, avoid poor man's cron, which does use, again, that destruct pattern of, when a service is destructed, it's processing cron jobs in that PHP process, which is now blocked there. So we look for asynchronous, opportunities wherever we can. And we also look to decrease the resource required by any individual process. Now, it's not uncommon for us to come into projects where the PHP memory limit, for example, is set to 256 megabytes, 512, a gig. And even if the PHP process doesn't need that much memory, if there are some that are using that much, well, goodness, what are the conditions that that produce that situation? What happens if all 20 of your PHP workers suddenly require a gig and you only have 8 gigabytes of memory on the web server? Well, I like maybe you're doing just fine, not solving the actual problem, but your Drupal application shouldn't need that much memory. And you will then fall all over yourself when you get to that point where scalability matters, where you have an email sent out and 100 people show up to buy from you all of a sudden. You don't want to be figuring out why your requests are eating up so much RAM then and be sending out 500 errors to shoppers because your server's running out of memory. You need to make sure that op cache is enabled, that you've right-sized the configuration, that if you have expensive operations loading up hundreds of entities to output 10 because pagination wasn't properly configured or access wasn't properly handled. I mean, like those are the kinds of things to look for in advance. In other words, don't wait for the site to come under load to then realize you have a memory problem or a CPU problem for that matter. And last but not least, I think Tom, you're probably a better person to speak to this issue than me. But we across our entire customer base, LLMs are a problem. And I know, I've had one customer, we just straight up blocked Singapore because we knew they were not selling to Singapore. And I knew that was a sort of a hotbed of LLM training because of their weak copyright law. But there's, aside from just blocking out entire regions of the world from accessing your website, there are other things that you can do, particularly when it comes to faceted catalog performance.
Agreed. Yeah, there's some of these bots can get in there and they kind of like circle on themselves, and suddenly you might have 5 or 6 facets on your search page, but somehow they're sending requests for 15 or 20 or 30 facets because they ended up getting in some kind of loop on themselves, adding facets on it. And it's weird because a bunch of these facets don't even have values, or they have repetitive values. Like going back to Ryan talked earlier about the year, make, model for auto. We're seeing requests come in with 15 facets, and it's basically year, make, model repeated 5 times. That's not helpful. Obviously, it's not going to actually get your end result that you're looking for on the search. It's just really a poorly written bot. And sometimes some of these are legitimate AI bots coming from like a Facebook or a Google or something like that, and just somehow they picked up something wrong on the facets and built it out weird. So we've had to do set up rules to kind of like rein those in.
Yeah, and the last thing you want is your customer with a $200 hosting bill suddenly getting a $1,000 hosting bill. And there's actually an interesting part of Pantheon's marketing lately. They're saying, hey, like we are charging by visit, but we're charging by human visit, not by bot visit. I think it's pretty interesting what they can do to detect bots and kind of weed through the data sets. Also, if you want to see the impact of AI on the web, Josh Koenig recently put out a really good report on essentially like CMS in the AI era. I can't remember the exact. It was the AI Realist Manifesto. I'll put this link in the chat. Simply because Pantheon has a global CDN that they route all of their requests through, and so they can see actually like what is bot traffic, what do LLM trainings look like, how can I differentiate and distinguish between the two. And I just thought that was really interesting insight from a kind of a player that has a 10,000-foot view across the whole of the web, and a healthy slice of the web, in fact. So that's interesting to check out. So again, just to recap, run those questions of caching. Is it enabled? Is it actually being used? Is anything breaking it? If you have things that are breaking cache, lazy load them, decouple those particular elements, whatever you need to do. When you get to the database performance level, make sure you don't have any quiet killers. Could one index, could one variable, could one optimization, speed up every request and unblock, those PHP workers. Because again, like if you have a slow query, if the query alone takes a half a second to run, well, if you get 100 PHP requests against a pool of 20 workers, Okay, you're resource constrained, and people are going to see long page load times, 3, 4, 5 seconds, just by a block database that might be better optimized. Take care of your technical debt and clean up the view sprawl, and again, push anything to asynchronous operations that you can. These are our tips here. Tom, just before we get into the concluding slide, 2 Q&A questions from the audience. First, what tools are we using to do sieges, stress tests? I mean, gosh, the last time I did it was with JMeter, and this was a while ago. So, what's
Yeah, and so I mean, and with that large client that we did with Acquia, I mean, Acquia actually had an enterprise tool suite that they were using for that. I'll just give you a simple one that worked with a smaller client, that identified some issues, and that was I had just created some playwright tests for them, and I just had 6 asynchronous playwright tests running, and that immediately identified an issue in that they couldn't take 6 requests coming in at the same time just from playwright spinning up and firing off those servers. Yeah. And I mean, and technically I should say that was actually 2 playwright tests, but I was running it under 3 different browsers. So it was like basically running like, Chrome and Firefox and I can't remember, Edge. But it was basically 2 tests running on 3 different browsers, basically 6, requests coming in, and it broke something. And so, that's something, we had to go back to the client and say, hey, you need to look at, this, whatever you're doing there, you have something that's breaking stuff. And that was just with playwright spinning up, a couple of tests across a couple of browsers. There's other tools out there. Let's see if we can get a recommended list.
Okay, great. Yeah, we can send that out in kind of the post show debrief. Last one was a question that essentially was just asking for a little more detail on views performance optimization, and I know that like how a view is built is of course a big factor in how performant the resulting query will end up being. And it seems like Rick also is already using a search API index on hosted Solr. So I guess the question is, what more can you do? Like, let's assume you have only the bare essential necessary query. You're already using a properly resourced external database through search API, so Solr index. Where would you look next to optimize the performance of that product catalog?
Let's see. So it is talking about doing searches. So I presume that there's, the parameters are going to change over time. But quite often people are searching for, similar products or same products. So I'm going to presume that there's at least some redundancy there where you're getting similar search terms or identical search terms. So if you're getting identical search terms, you want the CDN to take it over because then it's going to serve it immediately from its cache. And again, that's at the edge. So whatever zone, whether it's West Coast, East Coast, Europe, Asia, wherever they might be down in Australia, you're going to get, the quickest response if it's cached. Now, some of this gets into like how often does that data mutate? Because if your product information is constantly changing, that's going to impact that. Because even though you're putting it over in Search API, and that's an awesome way. Like we were talking, one of the items you talked about earlier, right, Ryan, is that there's some things where people are trying to do a contains, and that might be on a product description. And obviously, a product description might be a couple of paragraphs long. You can't really do a contains on or a starts with on that. But really what Search API does and other tools like it, well, not Search API itself, but I mean, the search engines behind it, what it does is it takes that description field and it basically creates a table of a bunch of word entries. And so it's doing a starts with on the words. That's actually what's happening behind the scenes. That's what makes the Solr and Elasticsearch and these other things much more performant on those like description field or product details fields. Is it's doing a begins with or a starts with search rather than contains, but it's split out all the words into a singular table. So using the search search API there with whatever your again Solr or Elasticsearch, those types of tools is definitely a good thing. One thing I would think about there when it is doing the views is, are your views just getting raw data fields, or is it actually loading up the entity behind the scenes for each row? Because certain views fields will actually load up the entire entity and then have to construct that potentially is going to, for each row in your query result, it's going to have to construct the entire entity and all of the additional tables that comes along with that. So one thing to consider is like, are you selecting only the fields that you need, and all of those fields raw data fields? If there's something that they're kind of calculated by the view field, then that's going to hurt that performance. So that would be one that I would look at in that area.
That actually reminds me of some performance optimization we did with Lush back in the day, where essentially, Lush had very robust product display pages with a lot of multimedia content, a lot of interconnected products, because they're like, hey, this soap has chamomile in it. What other products have chamomile? Oh, and it's like a color mood board. And they actually ended up pre-rendering every component of the page and putting that into the Solar Index. And so the response was actually just loading the pre-rendered thing, and it was still getting all of the filters and facets from the view's input, but the output was just pre-rendered HTML blobs constructed in the page where they needed to be. Oh, that was a really novel solution at the time.
Yeah. One other thing to think about there too, as we're talking about the products, again, without knowing what fields were in there, but think about something like stock. You wouldn't want to put stock in your search index there, because every time the stock changes, you're now, purging and, updating a row over on that, Solar backend, and you don't want to be doing that. You want that data to be fairly static. You want it to be the product descriptions, the titles, things of that nature. Something like stock that's very volatile, you don't want it in there. You want to handle that separately.
All right. Well, we'll run these questions by the rest of the Centaur team and include, all the responses in the follow-up. But I just want to say, thanks to everybody who came out to listen to us wax eloquent about Drupal Commerce. We love it. If you're experiencing issues and you feel kind of lost, we obviously would love to help you check it out and make it right. And of course, you can always get in touch with us at centaur.io, or email Ryan@centaur.io, Tom, etc. But Drupal Commerce it's our day job, and it's often our night job, and it's our fun job, and it's a platform that we really believe in, and we really see like our mission is to drive merchant success on Drupal Commerce. So if there's anything that we can do for you, obviously reach out. Otherwise, thanks to those that are in here that have been contributors, long-term users, or are part of the support community there in Drupal Slack. I just love the way that everybody's really present and there to help one another. I think that's what makes open source special. So thanks again for your time, and we'll see you next time.
Thanks, everyone.